Hello, I'm Professor Stephen Abbott. Welcome to this tutorial on the coffee drum roasting. So if you are a roaster of coffee, you'll have some idea of what we're seeing on the screen. You'll be familiar with the ET, the environment or exhaust temperature, and this is time. We've got 12 minutes here, and the temperature, all my temperatures are in centigrade, goes down with the ET and then it goes back up. You'll also be familiar with BT, the bean temperature. That starts off the same as the ET, and then it dips, and then there's the turning point here, and then it rises, and the bean gets roasted. And the rate of change, or the rate of rise of the bean, the ROR, is this blue curve, which is shown on the right-hand scale. At first, the temperature is falling, and then we don't see that, but then it rises, reaches a maximum, and then starts decreasing. And this strange point here is when the first crack takes place. We'll talk about that in a moment. That's a familiar set of graphs. This top one may not be so familiar. This is the IT, the inlet temperature. What I found is that it's impossible to have an app working using this ET because the ET is the result, it's the output of what happens, whereas the roasting is driven by the IT, the inlet temperature. Most of you don't record the IT, and it's difficult to do it exactly, but we'll just use it as a virtual exact input to the roasting. It's what drives the roast. During the roast, we tend to reduce the power of our flame. We turn the flame down, we turn the gas down. And I've described it as a power percentage. And if we started at full power right from the start, it would be at 100%. This yellow curve shows I'm starting at 90%, and then at a certain time, it decreases to 80%, and then it decreases to 70%. So I step it down. How do I specify that? Well, it's via this list here. I say that at 0, at the start, I have 90% power, and then when the temperature reaches 145 degrees, I want to reduce it to 80%, when it reaches 160 degrees, 70%, and so on. This is a set of comma-separated pairs defining what you want. You can have as many of them as you like to make it as complicated as you like. And then you see it here in the graph. If I want to change it, if I want the 180 to be 30% instead of 40%, I just type 30, I hit return, and now it's gone down to 30%. I'll restore it to the previous value just because I know what I'm doing. Whilst the coffee is roasting, it loses weight. It starts off with moisture in it, and gradually over time it loses that moisture. And this top curve here is the weight, with 100% being the starting point, and the weight gradually goes down. Suddenly at this point you see it decreases rapidly. We'll see why in a moment. This is the amount of water. Again, we start with the absolute percentage of water on the right-hand graph, and it decreases as the temperature gets hotter, and then suddenly at this point it decreases and you lose all the water, and that's why you lose the mass. So what's happening at this temperature? What's causing this change in ROR, and what's causing this? Well, of course, this is the first crack. And what we've done is that we've specified the temperature at which first crack happens. I've said it's 193 degrees. So when the bean temperature reaches 193 degrees, and you can always read off anything from the graph when you move your mouse, you see at this point, at this time, almost 192, 193. At 11.3 minutes, it's reached 193 degrees. That's the first crack. And it tells you that's 11 minutes and 13 seconds. We also are interested in the turning point, and so the time at which this starts ticking up is about 1.38 minutes there, and it tells you that's 1 minute and 23 seconds for the turning point. So these things which you are used to, the temperature for first crack, and the time for first crack, and then the time for the turning point are produced for you. That's the general app. What do we do to change it? Or we can change the weight of beans. So if I have a small load of beans, then of course they will heat up quickly and first crack will take place very fast. And if I have a large load, I will never reach first crack in the time scale I've set. I've said 12 minutes maximum. If I'm really using 12.8 gigs, then I need a longer time at these settings. So I increase here, keep going, and keep going. And then I see that first crack is after 16 minutes. You probably don't want to roast this way. So let me restore it back to the defaults. It's a really useful button. What else can I change? I can change the moisture in the beans. I can start off with really wet beans, and I can start off with really dry beans. It's my choice. Megajoules per hour. What does this mean? Your burner has some nominal output on it, often in thousands of kilojoules per hour, which are megajoules per hour. So you define it here. If at 100% you have a really powerful burner, then of course the time to roast will be much lower if I start at this 90%. And if I have a weaker burner, then 90% of that means I won't roast it at all. The temperature at which you start the beans can make a small difference. So I can alter that. The starting inlet temperature, most of the time we don't know because it's difficult to measure, but this app is letting us simulate it. So I can say, well, actually my roasting temperature starts at 250 degrees or it starts at 230 degrees. And so that scales the whole thing. The ET, the environment temperature, exhaust temperature, I'm just saying we don't know what it really is because it depends where you have the probe. And I can just say that I have this difference between the IT and the starting of the ET. So that allows us just to get a decent graph. You'll see in many roasting curves that ET varies quite significantly between different roasters, even though they might be roasting at the same temperature. We've talked about the temperature for first crack. We talked about the maximum time. We've talked about the difference. Many of you will change the drum speed or you'll change the air speed. That's a complicated effect. What I've done, let me just make sure I'm back at defaults. There we go. What I've done is so that if I rotate very slowly, then I'm not mixing up the beans enough. I'm not getting the air going in enough. So the roasting is slower. If I go faster, up to a speed of 3, then the roasting gets faster. But as is known, if you start going really fast, the beans get pinned to the drum by centrifugal force. Or if I introduce more air by having more suction, then that tends to cool things. So as you go faster, the roast gets slower. So a setting of 3 is the nominal one. Now you know that the temperature read out by these probes has a delay because you need to have an integration time, otherwise they're too noisy. To simulate that, we have the relative response curve, where 3 is nominal. If I make the response lower, then you see that everything changes because everything gets much slower to respond. And if I make it faster than 3, then things get sharper and noisier and you see all sorts of stuff happening. So this fast response is a more realistic curve if you could measure it, but in fact we can't because our probes have finite response and all that. So we'll tend to do it with a relative response of 3. And then we have the post-FC factor, the post-first crack factor. So after first crack, all sorts of things happen. First of all, the water is lost. That's fine. But then some people think that chemistry takes place and the beans can start to give out heat, they exotherm. And we can say, I don't want any of that, so I set that to 0. Or we can say, I want lots of that. And at the moment, we can't see much, so let me increase the time. So now I've got a large post-FC factor, and you'll see the ROR is now really taking off. What's happening there? Well, you're setting your beans on fire. That's unrealistic, but at the moment for this app, we don't really know what's going on around first crack. So this is just a way to highlight where you might get a crash and then a flick. So here's a flick. You definitely don't want a flick. Restore to defaults again. So now you've got the general idea of the app, and the text tells you all sorts of things. So it's all explained in detail, so you can read all through that stuff. How do we actually use it? Well, the thing you alter most are the power settings. So at the moment, this is a fairly steep decline and it's not really stable. You want a straighter ROR. So let's see how we can get it. So this is declining too fast. So this leap from 60 to 80 is probably, from 60 to 40 is probably too large. So let's go from 60 to 50. And again, you just, to change any of these things, you change them and then hit return, it works. So that's not too good. So we probably need to make this 65. Okay, so now that's getting slightly more level down here. And we get that. So with some more tuning, I could probably increase that a bit. So let's make that 75. Let's see what happens. There we go. That's now a steadier curve. This rise here is probably unwelcome. So let's take that down to 40 or 40. If I do it to 40, what happens? That's too fast. Let's make it to 45. So you can see the sorts of things which you try to tune on your machine, you can at least emulate in this T power percent setting. That's it. That's the app. But there's one more thing. How do we know this is true? The answer is you don't. This is just an app. I have lots of fudge factors and things. Those of you who can read code can just click this button here and you'll see all the code. That's all fine. So what I propose is that we as a community do something interesting. We find some bags of dummy beans, and dummy beans will have no water, and they have no first crack, nothing like that, and we look at what happens with these dummy beans. Now we tune the app so that what our roaster is doing to these dummy beans is nicely mimicked in the app. If we then have our standard bean settings, we first measure them with the dummy beans and then measure them with real beans. Any changes between the dummy and the real beans will be due to this water loss or the first crack or whatever. By being able to standardize it against dummy beans, we can get better understanding of what's going on. This is very much the first draft of this app. By the time you're watching this video, I hope I will have changed it and improved it. The point is that as a community, we can start using the app to debate what's going on, and I will happily refine the app at any time. You know where to find me with my email. There we go, the coffee drum roasting app. Enjoy.